A homework assignment once saved a Manhattan skyscraper. 59 floors, already finished, already full of people, and already one storm away from falling over. The building is Citicorp Center on Lexington Avenue in New York. When it opened in 1977, it was one of the tallest towers on Earth, and it looked like nothing else in the city because it was standing on stilts. 9 stories of open air underneath a 59-story tower. And the 4 legs holding all of it up were not on the corners. They sat in the middle of each wall. That one decision is the whole story. It wasn't a style choice. On that block sat a small church, and the congregation would only sell their land under one condition. A new church had to stand on the same corner, with nothing above it touching it. So the tower's chief engineer did something almost nobody would dare. He lifted an entire skyscraper over the church's head. Corners left empty. Legs moved to the middle. Problem solved beautifully. Now think about what that actually does. A normal tower puts its heaviest columns at the corners, because corners are where wind wants to twist a building. Move them to the middle of each face, and the corners have nothing underneath them at all. So the engineer hung the whole tower off a stack of giant steel chevrons. Rows of V-shaped braces, 8 stories tall, climbing all 4 faces like a spine. And it worked. The design was elegant, light, and used roughly half the steel a conventional tower of that size would need. Those braces even doubled as the wind system. Every gust that hit the building got funneled down through the V's and into the 4 legs. It passed every check the New York Building Code asked for. Every check the code asked for. Hold on to that sentence. There was one side effect. A tower that light sways, enough that people on the upper floors would feel genuinely seasick on a windy afternoon. So they parked a 400-ton block of concrete near the top, floating on a thin film of oil and tied to springs. The building leans one way, the block slides the other, and the sway cancels out. One of the first tuned mass dampers ever installed in an American skyscraper. It runs on electricity. Keep that in mind, it matters later. A student once called the engineer of a New York skyscraper to ask why the columns were in the wrong place. This was 1978. The tower was finished, occupied, 59 floors above Lexington Avenue. And the student, working on a class assignment, wanted to know why those columns weren't under the corners, where columns belong. The engineer explained the design politely, the way you explain something to somebody who hasn't seen the whole picture. Then he put the phone down and went and checked anyway. That phone call is the only reason the building is still there. Here's what he checked. Back then, the code only asked you to test wind blowing straight at a face of your tower. North, south, east, west. Nobody was required to test wind hitting the building on the diagonal, at 45 degrees to a corner. For an ordinary square tower with corner columns, that's fine. The diagonal case is the weaker one. But this tower's legs were in the middle of each face. Turn the wind 45 degrees, and it pushes on 2 faces at once. So he ran a diagonal wind through his own building. And the forces in some of those braces jumped by about 40%. 40% more load in a steel member nobody had ever designed for it. On its own, that would have been alarming enough. It wasn't on its own. Somewhere in your city, there is a building held together by a cost-saving nobody told the designer about. Citicorp Center's braces were drawn as welded joints. Solid, continuous, expensive. During construction, the steel contractor asked to bolt them together instead because bolting is faster and cheaper. And on an ordinary connection, it is completely normal engineering. The swap was approved as a routine substitution. This was not an ordinary building, and the man who designed it found that out 4 months after people had moved in. Put the two together, braces carrying 40% more force than anybody had calculated, held by connections weaker than the ones on the drawings. He worked out what the tower could actually survive, and the answer came in 2 versions. With that 400-ton damper sliding on its oil, a storm of the kind New York gets about once every 55 years. And if the power failed, which is exactly what happens in a big storm, the damper stops dead. Then it drops to once every 16 years. A 16-year storm. That is not a freak event. That is not a 100-year monster. That is just weather eventually. And failure here wouldn't have looked like a crack, or a lean, or a window popping out. Lose enough of that steel spine and the tower goes over. Onto Midtown Manhattan, in the middle of a working day. Now put yourself in his chair for a second. He was one of the most respected structural engineers in the country. Speaking up meant admitting in public that he had put 100,000 people in the path of his own mistake. Staying quiet meant gambling their lives on the weather. He picked up the phone. He told the owners, he told the architect, he told the city, and he did it within weeks. What happened next is the strangest construction job New York has ever run. Every evening, once the office workers went home, welders came up through the service lifts. They cut open the walls to expose the bolted joints and welded 2-inch thick steel plates over more than 200 of them. Every morning, the walls went back before the tenants arrived. Thousands of people worked in that tower all summer with no idea what was happening behind the drywall. In September 1978, a hurricane turned toward a Manhattan skyscraper that was quietly being held together by a night shift. Welders were still working inside the walls. Emergency generators had been wired to the damper. Weather scientists were tracking the Atlantic hour by hour, and the Red Cross had drawn an evacuation plan covering 10 city blocks. Then the storm Ella swung away and went out to sea. The welding finished a few weeks later, and the public heard nothing about any of it for 17 years. Here's the part that actually stays with me, and it isn't the hurricane. That tower was never wrong because somebody was lazy. It was wrong because every single person did their job correctly inside the box they had been handed. The code didn't ask about diagonal wind, so nobody checked diagonal wind. Bolting is a sensible swap on a normal building, and this was not a normal building. The flaw lived in the gap between two correct answers, which is why a student's question mattered more than anybody's calculation. They didn't catch the error. They asked the one question the process had no box for. Engineers still argue about who exactly made that call, and honestly, that feels about right. The person who saved 59 floors of Manhattan doesn't even get a name. Walk down Lexington Avenue today, and it's all still there. The stilts, the little church on the corner, and no sign whatsoever of the 200 welds hiding inside the walls. Which leaves one slightly uncomfortable thought. How many buildings are standing right now only because nobody has asked them the right question yet?